Alright, in this video we're going to look at numbers 6 and 7 from the circles test review. So let's go ahead and look at number 6. So for each of these parts, A, B, and C, they're asking us to find the area of the shaded region for the given circle. So let's first just talk about, let's start with talking about what the area of this entire circle would be. So for part A, we're looking at a circle. So you should remember the formula for the area of a circle is pi times the radius squared. So our radius here is 12 inches. So let's find the area for this entire circle. It's going to be pi times our radius, which is 12 inches, squared. So 12 squared is 144. So I'm going to leave this in terms of pi as 144 times pi. Pi is just a number, remember. So if I could multiply this in my calculator and get a decimal. But for right now, I just want to leave it in terms of pi. So 144 pi square inches. So that's the area of our total circle. We want to know the area of just this shaded region right here. And the other piece of information that we're given is that this central angle right here is 30 degrees. So we talked about central angles in the last video. This central angle means that the vertex of the angle is right at the center of the circle here. So we're looking at just this yellow section, which there's a couple ways you could think about this. The way that I like to think about this is I'm looking at this little piece right here. It's sort of like a slice of pizza out of the whole pizza. So we talked about in the last video that all of the central angles of a circle have to add up to 360 degrees. So in total, I'll just do this right here. So in total, we should have 360 degrees to make up our entire circle, but we're only looking at this little 30-degree slice. And so the way I like to think about it is I like to think about if I've got 30 degrees here, that's 30 degrees out of a total possible 360 degrees. So this is sort of like the fraction of the circle that I'm looking at. I'm only looking at the degrees from, I'm only looking at these 30 degrees right here, and that's it. So if I wanted to simplify this 30 over 360, I could put that in my calculator. Oops. So 30 divided by 360 is 0.88 or 0.083. Let's see if I can get that as a fraction. 1/12. Okay, good. So that's what I wanted. So in other words, what we're looking at here is 1/12 of the total circle, right? This 30 degrees. I could have 12 of these slices to make up my full circle. 12 of these slices would give me 360 degrees, which would give me a full circle. So we're only looking at one of them, 1/12 of this entire circle. So all you have to do now to find the area of the shaded region is just multiply the area of the total circle by the fraction of the circle that you actually want to know. So if I want to know what 1/12 of the total circle is, I would do 1/12 times 144 pi. And that would give me, I'm again going to leave it in terms of pi. So I would have 144 divided by 12. So that's just 12. I probably could have done that one in my head. So that would be 12 pi square inches, just for this little yellow slice right here. And again, pi is just a number. If I wanted to put that in my calculator and get a decimal value, which I don't think the question, oh, it does say round to the nearest tenth. So I guess we should probably put that as a decimal. So if we do 12 times second pi, we've got about 37.69, so we're going to round that to the nearest tenth, so 37.7. So this is roughly equal to 37.7 square inches. All right, so that is our answer for part A. So we took the fraction of the circle that we're looking at, which is just this right here, this sliver, and multiplied it by the area of the entire circle to get the area just of that small sliver. So let's look at number B, or part B. Part B, we're doing the same exact process. And the information that we're given here, we're not given the angle of the shaded area that we're looking at. We're given the angle of the unshaded area. So we know that this 90 degrees right here means that this box right here means that that's a right angle. So it's 90 degrees. So we've got a 90-degree arc here. And that means that if all of these have to add up to 360, the rest of this circle, the rest of the shaded region, should be 270 degrees. So in other words, the measure of this arc from here all the way around to here would be 270 degrees. So we're essentially looking at 270 degrees out of the total 360 degrees that are possible in this whole circle. So let's go ahead and get that as a fraction. That's how I like to think about this. You could leave it as 270 over 360. But for me, it's easier to think about if I can simplify it. And I think this one should simplify pretty well. So 270 divided by 360 will give me 0.75. And we know that 0.75 is the same thing as 3 over 4, 3/4. So we're essentially, what we're looking at is 3/4 of this circle. And we want to know what the area is. So now let's find the area of the entire circle. So the area of this circle, if we were looking at the whole thing, would be, again, pi a is equal to pi times the radius squared. So we're looking at pi times 4 feet squared. 4 squared is 16, so the area of this circle is 16 pi square feet, or feet squared. So that's our area. Now we need to multiply that by the fraction of the circle that we actually want to know. The shaded area only constitutes 3/4 of this circle. So we're looking at 3/4. So the area of the sector is going to be 3/4 times the area of the entire circle times 16 pi. So 3/4 times 16, 1/4 of 16 is 4. So 3/4 of 16 I think is going to be 12. It's going to be 3 times 4. So that should give us the final answer of 12 pi square feet. Or if we wanted a decimal, let's look at 12 pi. Well, it was the same. Yeah, that's the same as the answer for the last one. So 37.7 again. Square feet. So don't let that confuse you. This is just purely a coincidence that these two questions had the same numerical answer. These are two completely different circles with two completely different sectors. It just so happened that the numbers worked out that we ended up with the same numerical answer, but there's no relationship between those two that would always be the case or anything like that. So don't try to look for a pattern in there. That was just a coincidence. Okay, let's look at part C now. So this time we're given the length of the entire diameter. So the only thing that we've got to figure out now, or the extra added piece for this one, is to get a radius, because we can't find the area of this circle without the radius. So if we know that the diameter is 26 meters, we can say that the radius is 1/2 of that. So that's going to be 13 meters. So the area of this circle, the total area, is going to be pi times 13 meters squared, pi r squared. So 13 squared gives us 169. So that's 169 square meters. So 169 pi square meters is the area of the entire circle. Now another piece that they've given us here is that this central angle right here is 120 degrees, and we know that since this is a diameter, it's half of the circle. So half of the degrees of this circle have to be found from this line segment over to this line segment. So in other words, if this is 120, we need 60 more degrees in order to make this a 180 degree angle. Since it's half the circle, it should be 180. So we know that the angle for the actual area we're looking at is going to be 60 degrees. That's kind of hard to read. So this is going to be a 60 degree angle. So last piece now, we got to find what fraction of the circle are we looking at. If we're looking at 60 degrees out of a possible 360 degrees, we've got 60 degrees over 360 degrees. And I could look back here and see that if 30 over 360 was 1/12, I'm going to guess that this is going to be twice as big as that, since I've got 60 now, but we'll go ahead and put it in the calculator just to make sure. So 60 over 360 gives me a decimal. I want it as a fraction just to kind of wrap my head around it a little better. Yep, so 1/6. So twice as big as the fraction we had over here. So now we're looking at 1/6 of a circle whose total area is 169 meters squared. So the area of the sector area will be 1/6 times the area of the full circle, so 169 pi square meters. So the last piece here is just to figure out what that is. So if we do 169 divided by 6, Yep, so that's already going to give us an ugly decimal, so that's fine. So that's 169 divided by 6, but we also have to multiply by pi. Don't forget that. Sometimes people forget to multiply by pi. So that gives us 88.48, so we'll round that to the nearest tenth. So 88.5 square meters is the area of this shaded region of this circle right here. All right, and then with number 7, what they're asking us for is instead of the area of the shaded region, they want to know the arc length for the intercepted arc formed by the central angles that make up each of the shaded regions. So that's a really wordy way of saying they want to know the arc length of the arc bounding the shaded region. So in other words, for number 1, we want to know the arc length from here to here, right here. We want to know that arc length. And so again, we're going to use the same approach that we did last time. So arc length, we're looking at the actual linear distance from this point to this point. We're not looking for the angle. We know the angle for this arc is 30 degrees, but we want to know how far you actually would travel. So if this was like a racetrack, I would want to know how many inches. Well, racetrack's not a great example there, but I would want to know how far I'm actually traveling around the circle and from this point to this point. So to do that, let's look at the distance I would travel if I was going around the entire circle, just like we did with the area. So we know that the circumference, we call that the circumference of a circle, is equal to 2 pi times the radius. So just like before, I'm just going to plug in our radius here. So that's going to be 2 times 12 times pi. So 24 pi is the length, the distance I would travel if I was going around this entire circle. But now I want to know just the distance I would travel if I was just going along this arc right here from this point to this point. So to find that, we're going to do the same process. We're going to look at, well, this is a fraction of the entire circle. It's 30 degrees of a possible 360 degrees. So just like we did up here, we said that this shaded area right here is 1/12 of the entire circle. So instead of calculating 1/12 of the area, now we're going to calculate 1/12 of the diameter. I'm sorry, the circumference. 1/12 of the circumference of the circle, which we said was 24 pi inches. I always like to have my units on there. So 1/12 of 24. 24 divided by 12 is 2. So this is going to leave me with 2 pi inches. Now this is not inches squared because now we're looking at a distance, not an area. So 2 pi inches is how far I would travel from this point to this point right here. All right, so we're going to use the same process for part B and C. Let's see if we can do this a little quicker. So we want to find the total circumference of the circle for part B. So we're going to, let's say the circumference is 2 pi times the radius. So the radius here is 4 feet. So our circumference is going to be 8 pi feet. And then I'm going to go back up here just like we did before. We said that this shaded area right here was 3/4 of the entire circle. It was 270 over 360. So 3/4 of the entire circle is what we're looking at. So 3/4 times the circumference of the whole thing, so times 8 pi, will give us the distance from this point right here to this point down here. So if I traveled all the way around the circle from here to here, 3/4 of the way around the circle rather, what distance would that be? So we're looking at 3/4 times 8. I know 1/4 of 8 would be 2, so 3/4 should be 6. So that should give me 6 pi feet. Should be the distance around the circle, or the arc length of this arc created by this shaded region here. All right, and the last one, same thing. Now we're given a diameter, so we know another formula for the circumference of a circle is just pi times the diameter, and we're given the diameter right here, so we could say that that is just 26 pi meters would be the circumference of this whole thing. And we said that 60 degrees, which is this angle here, over 360 gives us 1/6. So we're looking at 1/6 of the entire circle. So if we have 1/6 of the entire circle times our circumference of 26 pi, sorry, can't forget my pi, meters, then this would give us 26 divided by 6, which I don't know off the top of my head. We'll just go ahead and do 26 pi divided by 6. That'll give me 13.6 meters to go around this far around the circle.